The graph of the relation x equals the absolute value of y minus 5 is shown. Use the graph to find the domain and range and indicate whether it's a graph of a function. So first off, don't be scared away by this being a function that has x solved in terms of y, which is a little bit different than what you're used to. All we really need is the graph itself. So the graph itself is a set of points, and to determine the domain of a set of points, what we need to do is find out all of the x values that have some associated y value. So for instance, if I chose -3, -3 has an associated y value in two different places, but that's okay, it's still part of the domain. As long as we pick any y value that happens to have an associated y value, any x value that is, that happens to have an associated y value anywhere, it's part of the domain. So it looks like -3 and -1 would be part of the domain, but -6, it doesn't touch the graph anywhere. So at -6, that's not actually part of the domain. So in order to really see the domain, one thing that you can sort of do is think in terms like that, or you could possibly consider if you take the graph of the function and you just smash everything up against the x-axis. Where that would smash is basically the domain of the function. Likewise, the range is just the opposite. So the range is all of the y values that have an associated x. So if you pick any y value, if it has an x value somewhere, it counts as part of the range. So 2 is in the range, -6 is in the range because somewhere I can find an x value associated with each y value. And similarly, if you can imagine the graph being smashed up against the y-axis, that's one way of seeing the range. Let me show you what I mean there. So here's our graph in a different place, but the graph itself is the same. And what I'm going to do is I'm going to take all the points on this graph and I'm going to smash them up against the x-axis so you can visually see what I'm referring to as the domain. So if I had like a trash compactor that was able to smash all the points up against the x-axis, this is effectively what it would look like, except for the fact that there technically are arrows indicating that the graph goes on to infinity and in this direction. But most graphing technology doesn't draw those arrows. And so we just have to assume that if there's no solid circle stopping us or a closed circle, or an open circle stopping us as well, that the graph goes on to infinity in the same direction. So if we saw the original graph, it starts right here, then goes to infinity in both directions this way. So when we actually see the domain, we are including the set from -5 to positive infinity. Okay, the range is similar, but if I had that same trash compactor smashing everything up against the y-axis, what I end up with is the range that is from -infinity to positive infinity. So that means there is a y value for every single, or sorry, there's an associated x value for every single y value in this graph. So as we said, the domain is the set from -5 to positive infinity. And we have a bracket on the -5 because that is inclusive. And then the range is from -infinity to positive infinity. Now the question is it a function? Well, it's a function if it passes the vertical line test. So a graph is a function if it passes the vertical line test. And the vertical line test means if you can draw a vertical line at every single point along the graph and it touches the graph at only a single point, at most one single point. If it touches the graph at more than one point, then it fails the vertical line test and it's not a function. So this particular graph, at most places, pretty much every place, the graph would touch a vertical line at two different spots, and therefore it fails the vertical line test, which means it's not a function. It's okay if you have vertical line that doesn't touch the graph at all, or, of course, if it touches at just a single point. But like I said, if there's a single place where the vertical line touches the graph at more than one place, it fails the vertical line test and it's not a function. So this one's clearly not a function.